Great. So what we've seen now is we can go and partition this into this way, and the beauty is if we do that. Okay, so I'm gonna wipe this off now because now we understand what this stands for. QU stands for this, QP stands for this, QUU is this little matrix, and in the end we can think of it as a small matrix, and the vector, this small matrix and that vector, etc. The force is also partitioned between the FU and the FP. Okay, so let's go and see what happens if we solve that in general. So this is now that we've done the effort of partitioning this properly, beautifully, and now we get the benefit of being able to solve the system. So this is the generic solution strategy that we follow in finite elements. And this approach is called the elimination approach. It's in the prescribed textbook. I'll tell you now which section. Let me just double check again. I think it's in section 3.8, called the elimination approach. This is what we're following here. So please go open up the textbook as well and see how they explain it. But I like this this approach, and hopefully this is clear what's going on. So I'm going to write the system down here again. Just copy it over. Maybe let's go back for this red one. I'm going to copy that system over. Say KUU, KPU, KUP, KPP, QU, QP. Okay. And if I want to solve this, the beauty is we can solve it very easily, saying, okay, what we know here is that the FPs, the prescribed display forces with prescribed, have those unknown R's. So we can't really use them at this stage, per se. Okay. So when it comes to sort of this set of equations, we can only use them afterwards because there are some unknowns in here as well. So there are unknowns here, the displacements, and there are some unknown reaction forces that we have to solve for. So we're going to have to start with the set of equations that are associated with the unknown displacements, because when I multiply this out, this multiplies by this plus this times this is equal to this, and so everything here is known. Okay, that is important to understand. And so what I'm going to do is I'm going to write this out as saying, to solve the system, to solve for QU, we're going to have KUU, QU. Okay, so this multiplied by this, these are the unknowns. This is a matrix, this is a vector. Man, this is going to be frustrating. Not just B, this is highly frustrating, the fact that these things are not writing nicely. Okay, so that's what we have. Next thing is KUP times QP. This is known and this is known. These are all the prescribed displacements. So these are the nodes. So this times this will go towards the other side. Okay, so I can say this is equal to FU minus KUP times QP. That's it. And now from this system, this is a small, this is a vector, this is a vector. Remember, this matrix times this vector will result in a vector. So these two I can subtract, and then I can solve for QU. So now we solve for QU. Okay. Once we've solved for QU, okay, we can go and say, now we can compute unknown reactions. And the way we go and do that is to say, okay, take these rows that we didn't use in solving for the unknowns. Essentially now we can just go and say this times this plus this times this is equal to FP. So we can go with unknown reactions, which is FP is equal to just KPU times QU plus KPP times QP. That's it. And there we've solved for the unknown reaction forces. It might be that some of the nodes has an unknown reaction force and that there's a contribution from the body force there. And so it will be then the unknown, let's say, R5 plus the contribution of the body force. But that is essentially the R5 plus that plus stuff. We'll just also move towards this side to isolate the unknown variable that we want to solve for. We had exactly that case. Go and look at that bar hanging in its own weight. there was a contribution of the body force at that prescribed displacement that we had to consider to make sure we computed everything correctly. So you can go and look at that example again in the tutorial. So this completes sort of the elimination approach for solving the system, from looking at an example in a concrete way, generalizing that, making sure that we understand that these matrices are partitioned, and then finally, once we have done that effort of partitioning, also understanding and appreciating the fact that we can then solve them in a nice generic way. Okay, so this is the elimination approach. This is the approach we will follow in this course. You don't have to look at the other approaches like the penalty approach, etc. We're only going to be focusing on this approach, and this is sort of the workhorse in finite elements.